In this video, I'm going to look at the logarithmic form of inverse hyperbolic functions. Let's start with y equals r sine x. If we've got y equals r sine x, then that follows that we must have x is equal to sine y, which is a half e to the y minus e to the minus y. Well, let's multiply both sides by 2 and by e to the y. I get 2x e to the y is equal to e to the 2y minus 1. Let's tidy that up. We get e to the 2y minus 2x e to the y minus 1 equals 0. Now this is a quadratic equation in e to the y, so we will get that e to the y is equal to minus b, which is 2x, plus or minus square root of b squared, which is 4x squared, minus 4ac is plus 4, divided by 2. And that is equal to x plus root x squared plus 1, or x minus root x squared plus 1. Now, in the latter case, this is going to be always negative. If x is a negative number, it's negative. If x is a positive number, root x squared plus 1 is bigger than x, so this is negative. So we can't use that. On the other hand, down here, if x is negative, this is a larger positive number in size, so the whole lot is positive. And if x is positive, this is positive. So this allows us to have e to the y for all values of x. Well, if that's e to the y, then y is equal to natural log of x plus root x squared plus 1, or we've shown that y, which is r sine x, is equal to the natural log of x plus root x squared plus 1, and this is true for all real numbers x. So there's the logarithmic form for r sine x. Let's have a look at arcosh x. We've got the graph of arcosh x over here, and x has to be greater than or equal to 1. Same trick. If y is arcosh x, then x is equal to cosh y, which is a half e to the y plus e to the minus y, multiplying both sides by 2, and also multiplying both sides by e to the y, we get e to the 2y plus 1, very similar to the last one. Tidy that up, we get e to the 2y minus 2x e to the y plus 1 is 0. That's a quadratic equation again in e to the y. E to the y is minus b plus or minus square root b squared, which is 4x squared, minus 4ac divided by 2a, and that's equal to x plus root x squared minus 1, or x minus root x squared minus 1. So this now gives us that y is equal to log x plus root x squared minus 1, or log x minus root x squared minus 1. I hope you've noticed you have a problem. For one value of x, we're only allowed one value of y for a function. And x has to be greater than or equal to 1. Well, if x is greater than or equal to 1, this is quite clearly and happily a positive number which is greater than or equal to 1. This is more interesting. This is very slightly less than x. When I do x minus root x squared minus 1, it will still be a positive number, but it will lie between 0 and 1. It is not part of the domain for y equals arcosh x. Alternatively, this is a number between 0 and 1. Its logarithm is therefore negative. It would be that part of the reflection of y equals cosh x which we don't allow in order to have a function. So we're not allowed the second part of this answer. So this tells us, let's just put that in, log x minus root x squared minus 1 is less than 0, and so not allowed. And that tells us that arcosh x, which is what y is equal to log x plus root x squared minus 1, and that works if x is greater than or equal to 1. So there's arcosh x, just a slight complication at the end. And let's move on to artanh x. Here's the graph of y equals artanh x, lies between minus 1 and 1, and so artanh x, its domain has to be mod x less than 1. So we play the same trick on this as we have done earlier. We get that x is equal to tanh y, and that is sine y over cosh y. Putting the formula in for sine and cosh, we get a half e to the y minus e to the minus y, all over a half e to the y plus e to the minus y. Cancel the halves, multiply top and bottom by e to the y, and we will get x is e to the 2y minus 1 over e to the 2y plus 1. Multiply up by e to the 2y plus 1, x e to the 2y plus x is e to the 2y minus 1. Tidy this up a little bit, and we get 1 plus x is e to the 2y minus x e to the 2y. That will give us that e to the 2y is 1 plus x over 1 minus x. Take logs and divide by 2. 1 plus x over 1 minus x. So that gives us that artanh x is equal to a half log 1 plus x over 1 minus x. And that is true when mod x is less than 1.